Hello friends, this is Jerry Thomas from Sakshi Apologetics network. We are continuing with our series on examining the Vedic Golden Age myths. And in this episode, we will be looking at the contribution of India to mathematics. Anyone who has studied the history of mathematics would definitely agree that India has contributed immensely for mathematics like any other civilization. India stands shoulder to shoulder to any ancient civilization in its contribution to mathematics. This was aptly summarized by Professor Amartya Sen, the Nobel laureate in economics, in its 2015 address to Infosys award ceremony. He said, "The golden age of Indian mathematics, which has changed the face of mathematics in the world, was roughly from the 5th to the 12th century, and its beginnings were directly inspired by what we Indians were learning from work done in Babylon, Greece and Rome." So we learned from Babylon, Greece and Rome, and then we developed it further. He says definitely India had its own analytical tradition, but we learned a lot about theorems and proofs and rigorous mathematical reasonings from the Greeks, the Romans and the Babylonians. And then we learned from others, we developed it and we gave it to others. So he says there is no shame in saying that we learned from others. So India stands as a sister civilization to any of the ancient civilization. But not everyone would agree with this assessment. For example, Swami Bharati Krishna Tirtha, who was the Shankaracharya of Govardha Math in Orissa from 1925 to 1960, he in his book Vedic Mathematics makes some astonishing claims. In the preface to the book Vedic Mathematics, he says, Vedas contain all the knowledge, not just limited to the spiritual area, but also to the temporal areas. And he says there are Indologists who says that Vedas doesn't contain any much knowledge and all. And to disprove them, he studied Vedas very meticulously. And to his astonishment, he found that the Vedas contain sutras which can solve all the mathematical problems in all the branches of mathematics. Now this is an astonishing claim. And it doesn't come from an ordinary Hindu. It comes from one who was the Shankaracharya of a prominent mutt. And in fact, he produced a book called Vedic Mathematics. Therefore, this calls for examination. So what we are going to do is this. We are going to first examine the evidence produced by Swamiji in his book Vedic Mathematics. We are going to raise some fundamental questions. And we are also going to examine the real contributions of India to mathematics and see whether those were derived from Vedas or whether those, as Professor Sen said, we learned it from others and we improved it and gave it back to others. So these are two different approaches or understandings or perspectives on the India's contribution to mathematics. So as part of this episode, we will look examining the evidence for the claim of Vedic mathematics. We will also look about the Pythagoras Theorem, what we call as Pythagoras Theorem, mentioned much before Pythagoras in Sulba Sutras. We will also look the most significant contribution that we gave the zero as a digit, which happened in the medieval times. And we will also look at the claim that calculus was invented in India, or to say it in a popular way, whether Isaac Newton stole the calculus from India. So we will look some genuine contributions as well as the astonishing claim that the Vedas contain all the knowledge And in this case, it contains the sutras to solve all the problems in mathematics. So let us begin by examining the claim of the Vedic mathematics itself. Swami Bharati-Krishna Tirtha has been preaching about the Vedic mathematics at various forums, and towards the end of his life, he started putting it in writing or composing it as different books. So he planned to write 16 books. Unfortunately, he died after he composed, in fact, the first volume. He couldn't complete the remaining 15 volumes as he claims it in the preface. But at least we have one book, the Vedic Mathematics, volume 1, as we can call it, to examine and check whether these claims are right or wrong. This book itself was published after the death of Swami. So we will begin by looking at it. Now there has been real research done on this book, and one of the person who has done tremendous research is Professor Sri Krishna Gopala Rao Dani, who is a professor of mathematics in the Indian Institute of Technology, Bombay, IIT Bombay. So Professor S.G. Dani raises a simple question. This book of Swami Bharati Krishna Tirtha has 16 sutras, and there are sub-sutras also, but primarily 16 sutras, which he claims are derived from the Vedas. So the first basic question is, where are the sutras mentioned in the Vedas? And to our surprise, the answer is nowhere. It is not just that it is not there in the Vedas, it is not there in any Sanskrit known literature. Now, this is not just the lack of awareness of Professor S.G. Dani and all. Professor K.S. Shukla is a scholar who contributed to our understanding of the ancient Indian mathematics. He has edited or written articles and books about the real contribution of the ancient Indian mathematics. So he is the right person. So when Swamiji was going around preaching this Vedic mathematics, one day Professor K.S. Shukla met Swamiji in person with an Atharva Veda copy, because Swami said these sutras are there in the Atharva Veda. So Professor K.S. Shukla went with the Atharva Veda and requested Swamiji to point out where in the Atharva Veda are these sutras, because Professor K.S. Shukla never saw it. However, Swamiji said these are there only in his personal copies and not there in any other text. So if you have the Atharva Veda, it is not there. It is there only in Swamiji's Atharva Veda. In other words, it is not there in the Atharva Veda. So this is where Professor S.G. Dani cites this incident and asks us a question: what justification is there for Swami to claim that it is in Atharva Veda when it is not there in any Sanskrit text? Now understand this. It is not there in Atharva Veda, that is fine. But at least if it was there in any Sanskrit text, we could have at least given him some credit. It is not there in any Sanskrit literature that we are aware of. In fact, this is in a way admitted in the Vedic mathematics book, the general editor's foreword. Professor Vasudeva Saran Agrawala, who was a Sanskritist and a grammarian, he was the general editor for the Vedic mathematics, the book, and in his foreword, he said, the question naturally arises as to whether the sutras from which form the basis of this treatise exist anywhere in the Vedic literature as known to us. And this, he says, those who critique Swami and say it is not there in any Sanskrit literature, they do not know how Swamiji approaches this question. And he goes on to quote Swamiji's preface and says, Swamiji had a reverential approach towards the Vedas. Swamiji believed that all the knowledge should contain in the Vedas. Therefore, it is not that these sutras were there in the Vedas. The sutras should have been there in the Vedas. That is what the Swami is claiming. Or this is trying to defend Swami from the general editor's perspective. When you read Swamiji's preface, Swamiji is trying to answer the Indologists who said that the Vedas does not have much knowledge. Now, to counter that, if you prepare something in Sanskrit and say this is part of the Vedas, who is going to accept it? And how is it going to answer the criticism that the Vedas does not have much knowledge? It is not going to answer that. So this is trying to defend Swamiji, but that doesn't hold good, or it is not convincing for a neutral, objective person. So the first problem with the Vedic mathematics is the so-called sutras mentioned by Swami is not there in any Sanskrit literature, and as of now we can certainly conclude these are or were written by Swami himself. How can you call that as Vedic mathematics? Second, Professor S.J. Danny also points out that this book Vedic mathematics, even the mathematics mentioned in the books, not just the sutras, even the mathematics mentioned in the book are not purely Indian. It has contributions of West up to even in the 16th century. For example, decimal fractions. Decimal fractions were not known to Indian mathematicians. For example, when Aryabhatta or Brahmagupta, they were not aware of the decimal fractions. Decimal fractions were popularized in the 17th century in John Napier's logarithm tables. That is what Professor S.G. Danny says. Now, Swamiji's book has decimal fractions. So it is not even Indian mathematics. It has taken contributions of the Western mathematics to it. Now, agreeing that the sutras are not mentioned in the Vedas, neither the mathematics itself is purely Indian. At least this question, has Swami developed any innovative method in solving the problems? Again, the answer is absolutely not. During that time, in the early 90s, the 1960s and before, there were many books in the Western countries which gave simple formulas or tips or shortcuts to solve mathematics. For example, Professor S.G. Danny himself cites the book by Lester Mayers on high-speed maths. Again, how to solve problems without following the steps, how to solve it easily. So there were many books like this. So Swami's Vedic mathematics was also a high-speed mathematics, but to get an aura, he wrote some of the citations in or the bullet points in Sanskrit. He could have written it in English also, and he should not have claimed that it was from Vedas. But had he done that, then the book would not have got the popularity that it has right now. So this is the case with the Vedic mathematics. Now we have seen that it is not there in the Vedas. It is not purely Indian. It is not unique on its own. And unfortunately, it is not even proper mathematics. If there are simple shortcuts to learn how to solve the problem, why are not the universities across the world teaching it? The answer is simple. As Professor S.G. Danny says, this can solve certain types of problems, but this cannot be universally applied. The tricks that are taught by Swamiji and others cannot be universally applied. it is better that you learn the principles and step-by-step solution, so you can apply this the principle to any type of problems. So it is better to learn, have a proper foundation, than to learn tricks given by Swami and the others. So it is not even proper mathematics. That is the case of the Vedic mathematics. Or to put it simply, Vedic mathematics is a fabrication done by Swami to claim that the Vedas has all the knowledge. Unfortunately, such kind of fabrications only boomerang. Now we can say that no matter what kind of evidence that we produce, the Hindutva crowd, it will go on repeating this. For example, G. Madhavan Nair, who was the former chairman of ISRO, he goes on to cite these 16 sutras as an evidence that Vedas were advanced in their knowledge. And you can see that clip.
Then this for computation purposes, at the time they had to memorize only 16 sutras. Using those sutras, they could find solutions to almost everything. So this is something amazing, and perhaps the modern the mathematics or the algebra and all those things owes its origin to this. In fact, many of the computer solutions what you are making today, this kind of sutras are very valuable.
But as we have already seen, this is an unfounded claim, a fabricated work, but it is being popularized again and again by the Hindutva crowd who wants to say that the Vedas contain all knowledge. Absolutely not. Now let us look at some of the real contribution. In this section, we will look at the Pythagoras Theorem mentioned in Sulba Sutras. Again, in 2015, then the Minister of the Union Minister of Science and Technology, Dr. Harshvardhan, said, our scientists discovered the Pythagoras Theorem and we very sophisticatedly gave the credit to the Greeks. Now there were many people who criticized it, but some people came in support of it. Dr. Sakshi, he said, don't debunk ancient science. And he said, the people who criticize Dr. Harshvardhan should know that he was speaking the truth. So we are going to check what exactly is our contribution in the Pythagoras Theorem. Now at that time itself, Professor Manjul Bhargava, who is a professor of mathematics at Princeton University, he had aptly summarized what exactly is a claim that we are making, or what exactly is a claim that we should make. And he said, the awareness of the Pythagoras Theorem was there with the Egyptians as early as BC 2500. There is no statement of the theorem anywhere in the Egypt at that time, but they seems to have had the knowledge, some knowledge of the Pythagoras Theorem, and as why we would see it shortly why he says that. Now the systematic listing of the Pythagoras Theorem, as he points out, was there in the Plimpton tablets in the Mesopotamia in BC 1800. So BC 2500 we had some evidence that the Greeks were aware of it, but by BC 1800 we have Babylonians actually listing it out. They were not explicitly stating the theorem, but they were listing it. As you would see the equation, the listing of the equation and all, you would see that they had the understanding of this Pythagoras theorem. That seems to be certain. So if we go by the awareness, the credit should go to the Egyptians. If we go by the listing, the credit should go to the Babylonian. Then comes the Sulba Sutras, which is generally dated from anywhere from BC 800 onwards to BC 500. You can date it. So let us take BC 800 as Dr. Manjul Bhargava took it. And then he says, we were the first ones in Sulba Sutras to explicitly state the theorem. So if you are going to take the standard that you should state the theorem, then the credit should come to us. The credit should go to Egyptians if you are taking the standard that you should be aware of it. If it is listing, it should go to Babylon. If it is stating the theorem, then definitely it should come to us. So there is a partial truth in what Dr. Harshvardhan says. But Dr. Manjul Bhargava goes on to say, see, for example, in history of mathematics, some historians would say that no, mathematics you have to give the proofs. So if we are looking for the first proof of Pythagoras theorem, then the credits will go to the Chinese. Because the Chinese were the first one to give the proof for this theorem. So depending upon which standard you are taking, you will have to agree that either it is the Egyptians, Babylonians, or the Indians or the Chinese. So it is up to you. So there is some truth, some element of truth in what Dr. Harshvardhan says, but it is not exactly that we discovered it and we gave it to the others. If discovery means you are aware, then it is Egyptians. If it is listing, then it is Babylon. If it is stating, then it is Indians. If it is giving proof, then it is Chinese. Pythagoras, attributing it to Pythagoras was an error in the history. That definitely we can all agree with it. Now, when we said the Egyptians were aware of it, let me give you some more of the proof. In the journal History Mathematica, which is the 1980 issue, Buttress Lumpkin says this evidence. Where it is there? It is there in the Berlin Papyrus. Now Berlin Papyrus, which was around BC 2500 and all, in that there are some mathematical equations, and Richard Glynns in his book Mathematics in the Times of Pharaoh shows how they solved it. And if you have to solve those equations, definitely you are aware of the Pythagoras theorem, or what we call as the Pythagoras theorem right now. You should be aware of that. Now in the same book, in the Mathematics in the Time of Pharaohs, Richard Glynns doesn't explicitly says that the Egyptians were aware of it, though he gives the solutions from where we can know that the Egyptians were aware of it. Richard Glynns in the same book, in the Mathematics of the Time of Pharaohs, states that the Babylonians were the ones who found the Pythagoras theorem. As he says, a second oddity in the history of mathematics was brought to light when the Babylonian clay tablet Plimpton 322, which is in the museum number, Columbia University, New York, was translated and published in the 1945. The translation established beyond any doubt that the Pythagorean theorem was well known to Babylonian mathematics more than 1,000 years before the Pythagoras was born. In fact, we can add more than almost 1,000 years before even Sulba Sutras were written. So this is the status. But at least we can say that there is some truth to what Dr. Harshvardhan says. However, Swami Bharati Krishna Tirtha always says that the Indologists are against India and all. But interestingly, this contribution, or that the fact that the Pythagoras theorem as a theorem was stated in the Sulba Sutra was brought to light by an Indologist, Dr. George Teiwert. He was the first one to translate and publish it, and he wrote an article in the Journal of the Asiatic Society of Bengal in 1875, and he pointed out that the Pythagoras theorem was already stated in the Sulba Sutras. So this is how it first came into the highlight. So Swami Bharati Krishna Tirtha, that all the Indologists are they have a condemned view of Vedas and all, are not true, as we see. Now what are the Sulba Sutras? Are they mathematical books? No. In the History of Indian Literature, Volume 4, Jyotish Shastra, Astral and Mathematical Literature, Chapter 1, Sulba Sutras, David Pingree gives a detailed explanation of it. As part of the Yajurveda rituals, they used to construct altars in different or sacrificial altars in different shapes. Each of the shape, they believed like if a person died and after that this is for the person to go to heaven or wherever he wants. And if you want to go to desiring to go to heaven, you have to construct an altar like a hawk altar. And if you want to desiring go to the other world, then you have to construct the altar with a different shape. If you want to go to your forefathers, then you have to construct an altar with another shape. So there were many different shapes of constructing this altar. How to construct that altar? The technical part is known as the Sulba Sutra. Sulba is the rope, so the measurement, how to construct that the altar. So this is not a mathematical book, but this is a technical know-how of how to construct a Vedic altar. As part of constructing the Vedic altar, this theorem also comes into play, because without knowing this theorem, you cannot construct the Vedic altar with the precision that it requires. However, the question is, are the Vedic priests who wanted to construct this altar, were they the same people who wrote the technique also? As George Talbot himself pointed out, that we can avoid the superstition. He himself seems to be differentiating between the superstition that is there with the technique that is given. So the question is, are the people who wrote the superstition the same as the people who wrote the technique? The answer again seems to be no. And there are many reasons for that. In the history of science and technology in ancient India, chapter 5, Mathematics in Making, Devi Prasad Chattopadhyaya points out that there is a social reason. One social reason is whether the Vedic priests would themselves involve in construction of this Vedic altars. The most likely answer is no. Now, there are other reasons. In the history of science and technology in ancient India, chapter 6, Technicians and the Vedic priests, again Devi Prasad cites that the book itself says they taught us, the authority says us, it has been said. So the author of the Sulba Sutras is not making a claim that he or his group of people has found it. They are always trying to cite others. So the book itself cites others, therefore it belongs to some others. That is very obvious. And again, not just the social context, not just the book actually cites others. As we already learned, the word Sulba is actually for the rope, but that is a Sanskrit word for the rope. Interestingly enough, that word is not the word used for rope inside the text. What is used inside the text is not the Sanskrit word, but the local word for the rock, which is Raju. So again, we seems to be going in the direction that this technique part is not given by the Vedic priest. The Vedic priest wanted to construct the Vedic altars, and here is a technique given by someone else. Now the question is, who are these people, or who were these people? Now, Devi Prasad proposes that they were the Indus Valley people, because definitely they know the brick making technology. It's known to the Indus Valley civilization, and therefore they could have been the people who provided this technique. When the Aryans migrated to India, they met the local people here, and these foreign Aryans learned the technique from the Indus Valley people. Now, it could be others also. For example, Fritstol, in the Greek and Vedic geometry, he says there is a lot of similarity between the Vedic and the Greek geometry. Therefore, they should have a common origin. And he also starts with the pointing out that the Rig Veda itself does not have any of these rituals of constructing these altars that we just now looked at. It does not have the different shapes of the altars that we are speaking about. It has very few references of the altars, and those altars are domestic altars for domestic sacrifices, not one for this elaborate public sacrifices that we had it in Yajur Veda. So this seems to have evolved at the time of Yajur Veda and not at the time of Rig Veda. Now he says, if we take the later archaeological evidences into consideration, what we are saying is the BMAC, which lasted only for a few hundred years, that is from between 2000 and 1500 BC. They seems to have had this knowledge, and they seems to have propagated it both to the Vedic people, the Greek people, and the others. And interestingly enough, the Indus Valley civilization had a close tie-up with this civilization, which lasted only for few years. So here we are. We can definitely claim that the Pythagoras theorem was first recorded as a theorem by the Indians. But exaggerating that claim and saying that we were the first one to discover it, it's not right. We were not the first one to be aware of it. We were not the first one to be listing it out. We were not the first one to give the proofs. We were the first one to record it. So that is a claim, and to that extent we can give credit to Dr. Harshvardhan, but not beyond that. Again, whether it has any relation to the Vedas, there is no intrinsic relation. If at all there is a relation, that is an accidental relation. Now let us come to the third part. Third part, as we all know, is the contribution of India, the contribution of zero. What constitutes a zero? In a paper, A History of Zero by J.J. Concor and E.F. Robertson of the School of Mathematics and Statistics of University of St. Andrews, Scotland, they provide a detailed research on this subject, and it is available on net. You can go, and it is worth reading it completely. So they are trying to highlight the real contribution of India in this aspect. So they look at the zero and they say there are at least two minimal requirements for zero as we right now know. One is the empty place indicator. Say example in 10, 1 and 0 after that. So that is the empty place indicator that the zero occupies as it. Second is the second use of zero is as a number itself. In the form we use it as zero. So you can multiply by 0 or divide by 0 or minus by 0 or plus by 0. 0 as a digit, we are going to use 0 as a digit. So that is the second use of 0. So what exactly did we contribute it? Or did we contribute it as a placeholder system? Did we start using it as a digit system? What exactly is our contribution? Now J.J. Concor and E.F. Robertson goes on to say, in another paper, not in the history of zero, in the Indian numerals, they say, see, India's Brahmi numerals did not have this zero as a placeholder system. For example, while it had, say, different symbols for 4, 5, 6, 7, 8, 9, they had also different symbols for 10, 100, 1000 and all, as well as 20, 30, 40, 90, all those digits. Now, if you are using placeholder system, 0 has a placeholder system, you need not have, say, a separate symbol for 20. You need to write 2 and 0, just like 1 and 0. You can easily understand it by looking at the Roman numerals now. They have different, say, for 70, it is a different symbol than 10. So that is where the Brahmi scripts were more or less like that. They had different symbols for, say, 20, 30, 40, 100 and all those things. So definitely we were not using 0 as a placeholder system in our ancient or the Indian numerals that we had. And we were definitely using this Brahmi numerals extensively up to the 4th century AD. So again, the point that it is not from Vedas is very clear as of now itself. However, there were people who were using a symbol in the place of 0. For example, again, Babylonians. Babylonians were geniuses in mathematics. So the Babylonians used a wedge for 0 in the place of 0 as we do right now. For example, in writing, say, the example given is 2016. So 2016 or 2, they will put a wedge and 16. Or in any other way, they will not put the wedge at the end. That is generally understood by the context. but they used to put wherever 0 comes in between a digit, they used to put a wedge. So they were the first one to use a placeholder system. But their placeholder, their digit system itself was not decimal. It was not based on 10. It was based on 60. So while they used the placeholder system, they were not following the decimal system that we as aware of or we are using right now. Now, Chinese, for example, Chinese had a counting board. Now, in the Chinese counting board, this is given in the Science and Civilization in China, Volume 3, Mathematics and Sciences of the Heavens and the Earth, Chapter 19 by Joseph Needham. He says the Chinese had 9 digits. They were not like symbols of 9 digits. They were in the Chinese counting board, which we have all seen, very similar to the abacus. So, Chinese counting board had a empty blank for 0. And they were almost using 0 as a digit. So, and they were using a decimal system. So, they were very close to what we call as the use of 0 right now. Or were the Chinese who discovered the 0? Absolutely not. So, what happened is we learned from both the Babylon and the Chinese. That is the scholarly conclusion now. And then we combined both. We combined both and we gave a new system to the world. We used the symbols for numerals, we used the placeholder system, and we used the 0 as a digit. We combined everything and we gave a new, very powerful contribution to the mathematics in the world at large. So there is nothing, as Professor Amartya Sen says, there is nothing to be ashamed. We learned it from others and we gave much more better to the world. But again, it is not from Vedas. Now there are people who try to minimize India's contribution in 0. For example, in A History of Mathematics, Chapter 10, Ancient and Medieval India, page 186 to 202, Carl B. Boyer and Utta S. C. Mersbach writes that with the introduction of the Hindu notation of the 10th numeral, they go on to say that it had to have a decimal base system, positional notation, a ciphered from each of the 10 numerals, and they go on to say not one of these 3 was originally devised by the Hindus, but it is presumably due to them that these 3 were linked to form the modern system of numeration. So, while they highlight the fact that seems to be trying to minimize the brilliance of the people who combined all these things together and gave it as in a new form to the world. But rather than being ashamed, we should be proud of it. As Joseph Needham wrote in Science and Civilization in China, Volume 3, Mathematics and the Sciences of the Heavens and the Earth, Chapter 19, Mathematics, he says, India was more receptive to the knowledge at that time than China. If Chinese were also receptive, they could have probably invented it much before us. So it was because of our receptive attitude that we could contribute. And today we are at a stage, we are working exactly the opposite of it. We want to claim everything as derived from Vedas and everything is there in the Vedas, and we want to be close-minded. But it was our open-mindedness that helped us to make this significant contribution to the world. Again, it is not Vedic mathematics, it is Indian mathematics. And because there is not much controversy over this subject of the contribution of 0 from anyone, I am not going to delve much into it. But if you are more interested in it, as I said, you can read J.J. Connor's A History of 0, which is available in the internet free, and that is a remarkable website to understand the history of mathematics, not just of India but of the other countries as well. Now we will look at the final piece, final section of this episode, whether the calculus was invented in India, and or as popularly it goes, whether the calculus was stolen by Sir Isaac Newton from Indians and he never gave the credit to the Indians, but he took the credit for himself. Is it true? Or what is the truth in it? So, again, it was a British civil servant who in 1833 wrote an article and published an article on the India's contribution in the infinite series. So the East India Company at that time wanted the civil servants to study the Indian calendar and how the Indians compute for the calendar, and they appointed 3 people, and one of them was Charles Matthew Wish. Again, in the website Max History St. Andrews AC UK, that same website that I was referring in the previous section, J.J. Connor, they give a biography of Charles Matthew Wish. He is the first person to find out from what we now know as the Kerala mathematics, and he published an article in the Journal of Transactions of Royal Society, Asiatic Society of Great Britain and Ireland, volume 3, issue number 3, titled as on the Hindu, the contribution of the infinite series, wherein he cited the Kerala mathematics, what we come known as the Kerala school of mathematics. And that he said, before Isaac Newton, the infinite series was there in the discovered in the Kerala. From that time onwards, initially it was ignored, but from 1950s onwards, this has come back in a huge way, claiming that we were the ones who invented the calculus. Now the story goes like that. Story goes like this. In the book Mathematics in India, chapter 7, School of Madhava in Kerala, page 217 to 253, Kim Florfer writes that the story is that Madhava, we will learn more about him, who was the founder, so-called founder of the Kerala school of mathematics. He had developed discovered a technique of finding infinite series, and through his successes that was developed. And the Jesuit missionary, the hypothesis suggests that the Jesuit missionaries who were in the vicinity of Cochin in the second half of the 16th century sought improved trigonometric and calendric methods in order to solve problems of navigation. And they found this Madhava's school of mathematics, and they in turn gave it to the West, and through the West it transferred and it came to the Sir Isaac Newton and all others studied. But as Kim Florfer writes, this is mere speculation without even an iota of evidence as of now. There is no evidence for this transmission at all. One of the person who propagates is George Georgis Joseph, who is a well-known mathematician and a historian of mathematics as well. In his book, The Crest of Peacock, the non-European roots of mathematics, chapter 10, A Passage to Infinity, the Kerala episode, he, while writing that this could have happened, he again starts with saying that it is a conjure. It is a speculation. And he goes on to say, all these are circumstantial. As of now, we don't have any hard evidence for this. So this is a claim. So what exactly is the contribution that we have? So Madhava, one of the Indian astrologers who lived in AD 1340 to 1425, in Irinjalakoda, Thrissur, Kerala, he had a tremendous discovery. His achievement was creating methods to compute accurate values for trigonometric functions by generating infinite series. So this was an excellent discovery found by Madhava. But the problem is, after this, it was only transmitted to his disciples. It was never known outside even Kerala. Forget about the Europe. It was not even known out other parts of India. David Pingree, in his article, The Logic of the Non-Western Science, Mathematical Discoveries in Medieval India, he says this. He says, if you look at the way all the textbook of the Kerala mathematics, all the books of the Kerala mathematics and the prominent people of the Kerala mathematics, it never traveled beyond 100 miles. And that too, I would add, within the Brahminical class only. It was not even known. Until Charles Wish took it and popularized it, nobody knew about it. The question of transmission then doesn't arrive. Now that is not the only thing, that we don't have any hard evidences for transmission, and it was never was known outside Kerala until the Westerners popularized it. We have actually a positive case to state that Isaac Newton did not know it. For the simple reason, we have his notebooks. And in his notebook, when we look at it, he shows no awareness of any Indian mathematics on this aspect. in A History of Mathematics, an introduction, chapter 8, Ancient and Medieval India, page 260, Victor J. Katz writes, in the case of Isaac Newton, we can trace his thoughts through his notebooks and therefore have no reason to believe that he was aware of the Indian material. So not only that we don't have an hard evidence, the evidence that whatever materials that we have, it doesn't show any awareness. So this is mere speculation. Now this is not the only problem of what Madhava has found and what others have propagated. There is more a fundamental problem to it, that it was not calculus. That is the fundamental problem to it. We are saying that Isaac Newton stole the calculus from Kerala School of Mathematics, but what Kerala School of found was not calculus. At the best we can say it was one part of calculus. Even in the Crest of the Peacock, Non-European Roots of Mathematics, chapter 10, George Georgis Joseph, he says two powerful tools contributed to the creation of modern mathematics in the 17th century, the discovery of general algorithm of calculus and the development of application of infinite series techniques. So, it is not calculus as completely. It is just one of the part of it as best as you can say. Now this is admitted even by those who propagate it. But there are others who refute it and say that this has nothing, this is not calculus. For example, in the Sherlock Holmes in Babylon and other tales of mathematical history by Marlowe Andrewson, Victor Katz and Robin Wilson, Victor J. Katz writes, how close did these Indians and even Islamic scholars came to inventing the calculus? So that is another story. In the 10th century, Islamic scholars also had discovered a part of it. They have also not found the full, the calculus as we right now know it. So he goes on to say about the Islamic scholars, and he even says the Indian scholars, and says that they nowhere came close to what we know as calculus. And he says about the Newton and the Leibniz who invented the calculus, they were certainly the ones who were able to combine many differing ideas under the two unifying themes of the derivative and integral and show the connection between them and turn the calculus into a great problem solving tool we have today. So this is like saying that if we apply the same mentality in the say the contribution of zero, the Chinese can claim that they were the ones who discovered the zero and we generally stole it. Of course we will not agree for that. Even when there is a clear case of transmission, because we have clear cases of Buddhist monks coming and the evidence for the zero is found in the discovery in the border of the countries. So we have actually much more clear case of transmission. Then they can make an even more bigger claim. But we claim that zero is our contribution, and in the same way calculus was contributed by Newton and the Western scholars. It was not founded by the Kerala mathematicians, though Kerala mathematicians were brilliant enough to propose the infinite series. Again, in the Sherlock Holmes in Babylon, was calculus invented in India? Mathematical Journal. David Bruce, another scholar, says, no, calculus was not invented in India. But 200 years before Newton or Leibniz, Indian astronomers came very close to creating what we could call as calculus, but they did not create it. That David Pingree writes in Hellenophilia versus the History of Science, in volume 83, he gives us a very good insight. He says when people write about the mathematics, they have a tendency to see everything through the Western system. So if the Western system uses calculus to solve the infinite series, and if somebody solves the infinite series, then it must be calculus. So he says it is wrong. In the Western system, you have the infinite series of trigonometric functions and all through calculus. But in the other systems, there are other systems where you have the infinite series without the calculus. And he goes on to say, take the example of the India Madhava demonstration in 1400 AD. The infinite power series of trigonometric functions using geometrical and algebraical arguments. When this was first described in English by Charles Matthew Wish in the 1830s, it was heralded as India's discovery of calculus. And he goes on to say, but this is wrong. What Madhava has found was, we understand the clever way that Madhava derived the series without the calculus. So this is the case. Kerala School of Mathematics had infinite series without the calculus. What Isaac Newton discovered or invented was the calculus. It was not the infinite series which Madhava proposed. These are two different systems and we need not club it. Now this no way reduces the brilliance of Madhava of the Kerala School of Mathematics. The question is, could Madhava contributed like Sir Isaac Newton if he had the opportunity? That is the question that we should ask. Why did two brilliant mathematicians, one contributed immensely and the other showed his brilliance but had no practical contribution of a real problem solving skills? The answer is in the system. While Sir Isaac Newton worked in the astronomy, Madhava worked in the astrology, and in Madhava's astrology, the infinite series without calculus was the only needed thing. So what he needed, he found. Whereas Isaac Newton had the real system of astronomy and he had to invent a much more brilliant way, and therefore he was forced to. Both of them probably would have been same in the brilliance, but the system made the difference. So rather than taking the credit, the Vedic system taking the credit for the infinite series, rather they should actually take the blame for containing the brilliance of Madhava. In fact, the question that why it didn't go outside Kerala is also another question, because of the Brahmanical system. If it were not for the Brahmanical system, Madhava's infinite series would have been published in journal, and then it would have been, the other scholars would have made use of it. But unfortunately, the Brahmanical system killed the brilliance rather than allowing the brilliance to blossom. So here we see, in other words, rather than contributing, if at all the Vedic system has done something, it has actually killed the brilliance. So there is nothing called Vedic mathematics, and there were brilliant contributions in Indian mathematics, but those were all individual contributions. Vedas incidentally would have contributed something like in the Pythagoras Theorem in Sulba Sutras, but generally Vedas were not conducive for the development of the modern mathematics. In fact, we must reject all claims of Vedas having any knowledge or having all knowledge. Definitely we must reject that claim, and we must continue to in the path. That is what Professor Amartya Sen said. We must take knowledge from all the civilizations and improve upon it and give it back to the others. I will end with this quote. In the Sherlock Holmes in Babylon, was calculus invented in India? Mathematics Journal 2002. David Bersaud laments and says, I am left wondering how much important mathematics is today known but not yet discovered, passed among my coterie of tightly knit disciples as an intriguing yet seamlessly useless insight lacking the context, the fertilizing connections that would enable it to blossom and produce its fruit. So the real question is, how much the Vedic system and the caste system has killed the brilliance of the Indians rather than allowing it to blossom. May that thought make us ponder on whether this system itself is good to continue. In fact, if Madhava had a system, the biblical system that Isaac Newton had, we would have taken the credit of discovering the calculus, and we would have been contributing to the world. And it is not too late for us to change our system. This is the right time to ask the right questions and to not only to bust the claim of the Vedic mathematics, but to show the way how Indians can contribute to the real scholarship in the world. May God help us to, all of us, to open our eyes and ponder on these questions and make real changes in India, so that India will become a powerful nation in the modern society. Thank you for listening, and may God bless you all.